Okay, so we're going to take a look at some 2B solving questions from Unit 9. So I'm going to do a couple with you from the extension document that you see on Canvas. So let's start with question 4. Question 4 says that we're given some angle. We know that angle is in quadrant 2. And we know that the sine of that angle is positive root 2 over 2. So then once we think about what that means, we want to figure out what is tangent of that same angle. So it would really help me if I could figure out what angle we're talking about. So I'm going to draw this out. And I'm going to ask myself, where is sine of theta positive? And that's just these two quadrants, right? The other two quadrants, sine of theta is negative. And I'm also going to ask myself, when is that value of sine going to be root 2 over 2? And we know that's here at my 45-degree angles, or at my pi over 4s, right? So there's my two angles that are where sine of theta is positive root 2 over 2. But there's something important here. It tells us that theta is in quadrant 2. So that means we're really just talking about this angle right here. So now I know what my angle is. My angle is 3 pi over 4. And if I want to find tangent of 3 pi over 4, I just need to know the ordered pair. So the ordered pair at 3 pi over 4 is negative root 2 over 2, positive root 2 over 2. And we know that tangent of theta is equal to y over x, which means tangent of theta is going to be equal to positive root 2 over 2 divided by negative root 2 over 2, which gives us that tangent of theta equals negative 1. So go ahead and try questions 5 through 7. They are kind of like that question. And then when you're ready, you can take a look at an example from question 8. So I'm going to do example 8 with you, two parts of it. So this question is asking us, how many solutions does cosine of theta equal to negative 1 have over the interval? So let's think about what this means. Solutions means we're solving this equation. When I look at this equation, the variable that we have is theta. What we're trying to figure out is how many answers are there to this equation? How many angles give us a cosine value of negative 1/2? So the best way to do this is to start by thinking about where are the one or two angles between 0 and 2 pi that have a cosine value of negative 1/2. That's where I want to start. So cosine is negative. I know that the two quadrants that cosine is negative are these two. So I know I'm thinking about those two quadrants. And where is cosine, the x value, negative 1/2? That's going to be our angles that have a reference angle here, pi over 3. So those are my two angles that we can think of from the unit circle that give us a cosine value of negative 1/2. But we know those are not the only two angles that exist with that value. They just happen to be the two from our unit circle, from 0 to 2 pi. So now we have to look at our interval, and we have to decide, are both of these in our interval, are neither, are some? And we have to kind of think about other possible coterminal angles that might exist in that interval. So this first interval is just from 0 to 2 pi. So I can actually easily travel that or draw that into my graph. So from 0 to 2 pi, I would travel this way. And so I see that both this angle and this angle are both within 0 and 2 pi. So that is two solutions in our interval. And it can be helpful sometimes for people to think about what quadrants those are in. That's in quadrant 2 and quadrant 3 are our two solutions. Now, let's think about when our interval is not 0 to 2 pi, because like we said, we know there's more angles out there. So I'm going to put that same drawing. I'm going to use this drawing to help me start thinking about this. And I'm going to think about all the angles that are coterminal with these two between negative 540 degrees and 540 degrees. And to help myself, I'm going to actually split this into two parts. I'm going to think about from negative 540 degrees to 0. And I'm also going to think about from 0 to 540 degrees. So I'm going to split this interval into two parts because it just makes it a little easier to draw. So if I'm going 0 and negative 540 degrees, negative 540 degrees would look like this. We'd go 360 degrees, and then we'd go 180 more. So what this drawing tells me is that I have one solution in the second quadrant, but I actually have two solutions in the third quadrant. Okay? Those are two angles that are coterminal, and they both fall within our interval. So from this part of our interval, we have three solutions. And then I'm going to look from 0 to 540. So now I'm traveling in the positive direction. That's going to be a full 360 degrees. And then another 180. And so from this part of my interval, I have one solution in the third quadrant. And I have two solutions, two angles, in the second quadrant because we are actually hitting that angle twice, right? That coterminal angle. So there are three solutions from this part, three solutions from that part. So total, I have 6 solutions, 6 angles in that interval that would make a cosine value of negative 1/2. So go ahead and try 8, 9, and 10. And I'm going to go ahead and give you an example for question 11. So if I take a look at example 11, this problem is very similar, but instead of saying determine how many solutions in the interval we have, it's asking us to actually find the solutions. What are the possible values of theta? So my process is going to look pretty similar. I'm going to start out by drawing where do I have cosine values of 0. Where is x 0 on the unit circle? And so I know that that's here and here, right? That's when x has a value of 0. And then I'm going to ask myself, okay, well, which of these values, or are there other values between 0 and 2 pi? So if I go from 0 to 2 pi, both of these angles are within my interval for my solutions. So I have two solutions. But this doesn't ask me how many solutions, it asks me what the solutions are. So I'm thinking to myself, well, what is that first angle? That's pi over 2. And what is that second angle that's in the solution set? That's 3 pi over 2. So my two possible solutions are pi over 2 and 3 pi over 2. So go ahead and consider these problems, give them a try, and we're here if you need us.